We're looking for the magnetic field produced by a current flowing through a long straight wire. Our equation to find that is B for magnetic field is the magnetic constant mu, Greek letter M for magnetism, divided by 2 pi, multiplied by current divided by R. If you take a closer look, it didn't really show up in the proof that well. It's obviously that's a calculus thing again, but the denominator is really 2 pi r. It's there, it's an artifact from the math. It's the circumference of the cylinder that we're picturing. It's a calculus thing that when your calculus gets a little bit better, maybe in university, you'll derive this equation and you'll see why it has to be 2 pi r. But for now, just think of the 2 pi as being part of that constant. For the numbers in this question, the magnetic field constant, well, it's always, when we're in air, it's always 4 pi times 10 to the negative 7. It's got some funny units that make it work out, so we end up with a number in teslas. We're going to divide that by 2 pi. We're going to multiply that by our current of 5. And our R value that we're interested in is 15 centimeters away from the wire. So put that in meters to be 0.15. Doing the math on that, when I crank that out, we get a small number, 6.7 times 10 to the negative 6, and that's a number in teslas. That's part of the answer. The second part is the left-hand, right-hand rule, which is going to be a little bit tricky to do on an iPad, but I'll kind of talk you through it. This question says that it's electron flow. So use your left hand, point your left hand towards the ceiling. So hitchhiker hand, left thumb pointed towards the ceiling. I'm curious about what's happening to the right of the wire. So with your left hand, left thumb pointed towards the ceiling, to the right, your fingers are pointed out of the page or towards you. So in this case, so the add-on from what we did in grade 11. In grade 11, I wouldn't have given you the numbers, just would have expected you to do the left-hand, right-hand rule. For grade 12, though, we're going to go one step further. Now that we've got this equation, we can actually get a